Hello dear students, welcome to this video. This video is in continuation to my previous videos on the topic of Introduction to Trigonometry. We have already discussed this topic. We have discussed the T ratios of specific angles, T ratios of complementary angles. Then we took trigonometric identities. In the last video we couldn't finish T identities. If you remember, we finished the one identity we derived, that was sine square theta plus cos square theta is 1. In this video, we will be taking the rest of the identities. We will derive those identities and apply those identities in proving different identities as per your textbook is concerned. If time permits, I will take some questions beyond the textbook. So let me first write those identities which we discussed last time. We only derived one identity. Our three basic identities are sine square theta plus cos square theta is equal to 1. This identity we derived last time. Now we have two more identities related with this. This was the first one. The second one is 1 plus tan square theta is equal to secant square theta. And third one is 1 plus cot square theta, that is equal to cosec square theta. If you remember last time, I said these three identities are the basic identities. They are also known as Pythagorean identities, or they are also known as squared results because of the square. And observe the relation of two trigonometric T ratios. Like in first identity, you have a relation between sine and cos. Sine square plus cos square is 1. If you further simplify this identity, sine square plus cos square is 1, which we derived last time, we can prepare one more result, that is sine square theta is 1 minus cos square theta, and cos square theta is equal to 1 minus sine square theta. So I'd ask you that do remember sine is related with cos. Previously sine was related with cos as for complementary angles were concerned, and as far reciprocal results are concerned, sine is related with cosec. Now second result is 1 plus tan square is secant square theta. This is also to be derived the same way we derived the first result. You go to a right angle triangle, you apply the Pythagorean theorem, and you get the result. And observe that tan is related with secant, and secant is related with tan, but tan is already related to cot in terms of the reciprocal result, and in terms of complementary angles, tan is related with secant in that case. No, tan is related with cot as for reciprocal. I repeat, tan is related with cot as for reciprocal. As for complementary, tan is related with cot. As for this result, tan is related with secant. And same goes to 1 plus cot square is cosec square theta. Let me prove one of the results. Maybe you have forgotten. So first is already done. Now let's take 1 plus tan is secant square theta. So we will take a right angle triangle as usual. This is my right angle triangle ABC. Right angle at B. Let me take this as theta. So we have to prove 1 plus tan square is secant square theta. So in that right angle triangle ABC, let me apply the Pythagorean theorem. In right angle triangle ABC, apply Pythagoras theorem. So we have, I could write it this way, AB square plus BC square is AC square. Usually we write AC square is AB square plus BC square. But I'm expressing it this way because I have a sum on the left hand side of the result that I have to derive. So AB square is BC square equal to AC square. Now, if you observe the result that you have to prove, you want secant square on the right hand side. And what is secant? Secant is hypotenuse by base, because cos is base by hypotenuse, so secant is hypotenuse by base. In this case, hypotenuse is AC and base is AB. So I want secant square theta. That means secant square theta will be AC square by AB square. I already have AC, so you want AC to be divided by AB square. AC square to be divided by AB square so that you get the right hand side. So we'll do the same. We'll divide both sides of this equation by AB square. So when we divide, we get AB square upon AB square plus BC square upon AB square is equal to AC square upon AB square. It's simplified. AB by AB square is 1 plus this could be written as BC by AB whole square, and this is AC by AB whole square. Now this will be 1 plus BC by AB. BC by AB is tan, because BC is perpendicular, AB is the base. So this is tan. And what's the angle involved? Tan of theta. So this will be tan square theta equal to, and AC by AB square, that is nothing but secant square, angle has to be written theta, sec square theta. So 1 plus tan square theta is secant square theta. We derived this moving into the right angle triangle. Now what are the other versions of 1 plus tan square theta is secant square theta? You could say secant square theta minus tan square theta is 1. That will be one way of expressing it. Secant square minus tan square theta is 1. See, if you are asked to prove secant square minus tan square is 1, it's the same result. One more would be, so tan square theta is equal to secant square theta minus 1. So each result is giving you two smaller results. You could say they are corollaries. So total you have 2, 2, 4, 2, 6 results. And these happen to be the basic 3 trigonometric identities. Now with the help of these 3 identities, we are asked to prove, to verify so many identities. As your textbook is concerned, you have 10 identities given in question number 5. And as for the rest of the questions are also concerned, we are dealing with identities. But first I would like to do question number 1 and question 2 of your textbook. That's exercise 8.4, page 193. Now what is this question all about? These are 2 questions. They are based on identities as well as the reciprocal results. Now out of 6 T ratios, if we take any one T ratio, any one you are interested in, for example tan, now the remaining 5 of them, they can be expressed in terms of a single T ratio. I repeat, in trigonometry, any of the T ratios could be expressed in terms of a single T ratio. So let's see how we are going to do that. We'll be taking help of these identities as well as the reciprocal results to reach as what we are asked to do. So this is exercise 8.4. Question number 1. Question number 1 of this exercise, it says express the trigonometric ratios of sine A, secant A and tan in terms of cot. So he has identified cot, asking you to express sine, secant and tan in terms of cot. Question 2 says write all other trigonometric ratios of angle A in terms of secant of A. Let me take this one second, because you have to express all 5 in terms of secant. So all 5 T ratios to be expressed in terms of secant of A. That is your question number 2. So this is my question number 2. So he has identified secant of A. So remaining 5 to be expressed in terms of secant. Now how we go about it? I will first take cos. Because my dear friends, cos of A is a reciprocal of secant of A. So cos is secant 1 by secant. So we succeeded. So cos I wrote in terms of secant. Now next let me take sine now. How to express sine in terms of secant. Now see how the link is there. Sine is to be expressed in terms of secant, because we have been asked to express all in terms of secant. Now how sine will jump to secant? Now if you take the identity, sine can be expressed in terms of cos. Sine can be expressed in terms of cos using the identity, because sine square plus cos square is 1. So sine of A will be square root of 1 minus cos square A. And cos we have already expressed in terms of secant. See, I will show you how this works. My dear friends, sine square theta plus cos square theta is 1. So your sine square theta will be 1 minus cos square theta. That means your sine of theta is 1 minus cos square theta, square root of that. So I could express sine as 1 minus cos square A, square root of that. Sine in terms of cos. Now cos we have already written in terms of secant. So this will be 1 minus 1 by secant square A. You could simplify it further. This will be secant square A minus 1 whole upon secant square to be taken out of the square root. That is secant of A. So sine in terms of secant. Cos in terms of secant. Now sine in terms of secant. Now sine will help us to prepare cosec. Now I will write cosec of A. Cosec is a reciprocal of sine, so reciprocate it. That would be secant A upon secant square A minus 1. So we have succeeded in expressing 3 t ratios. Now what about the next? Let me move on to tan. Now tan, how tan can be expressed in terms of secant? Again move to the identity. You have 1 plus tan square is secant square. So see 1 plus tan square A is secant square A. So that means tan square A is secant square A minus 1. And if you take the square root, your tan will be in terms of secant. So tan A is secant square A minus 1. So this is tan in terms of secant. Now the last one is cot of A. That is reciprocal of tan. This will be 1 upon secant square A minus 1. So all t ratios could be expressed in terms of a single t ratio, whichever t ratio you are interested. Now you could try the first one using the same logic. We'll move further. Okay, that was question number 2. Let me move on to question number 3. We are asked to evaluate. Let me write the question. This is question number 3. Sine square 63 degrees plus sine square 27 degrees divided by cos square 17 degrees plus cos square 73 degrees. 63, 27, 17 and 73. It's an observation usually as for trigonometric identities. In short, I call them as T identities are concerned. You get questions in terms of verifying. There is an identity, you have to show this is equal to this, left hand side equal to right hand side. But we have a question based on identities wherein you are asked to evaluate the value of this expression, trigonometric expression. So if we make an observation, my dear friends, 63 and 27, they are complementary. They sum up to 90, same as 17 and 73. So do remember in the previous videos, for complementary angles, we said that when you have two angles that sum up to 90, they are said to be complementary angles, and you have a result that sine 90 minus theta is cos theta, cos 90 minus theta is sine, tan is cot, and cot is tan, and so on. So what we'll do, and we change one of the angles. Let me change this angle. So sine 63, I will write using result sine of theta. That is cos of 90 minus theta. Sine theta is cos 90 minus theta. So this will be cos of 90 minus theta. Now if sine of theta is cos 90 minus theta, so sine square theta will be also cos square 90 minus theta. Whatever powers you raise on both sides, that means sine cube theta will be cos cube 90 minus theta. This is minus. So I've used sine of 63 as a result. Sine is cos 90 minus theta, square of this. This will be plus, keeping the other as it is, 27, and let me change 17 here. So cos of theta will be sine of 90 minus theta. Theta is 17. Square of that plus cos square 73 degrees. So if we further simplify this, this will be cos square 90 minus 63 will be 27 degrees plus sine square 27 degrees. And what about this? This has to be sine square 90 minus 17 will be 73 degrees plus cos square 73 degrees. So what we are going to do now? We are going to use the identity sine square theta plus cos square theta is 1. Your theta in this case is 27. Sine square theta plus cos square theta has to be 1. upon sine square theta. Theta is 73 in this case, plus cos square theta, that's 1. So the final answer is 1. So we have used two results as for this question was concerned. You have used the T ratios of complementary angles as well as T identities. Now we'll move on further. The second part of the same question is on the same lines, like sine 25, cos 65, cos 25 and sine 65, and 65 and 25, they are complementary, so you use the same logic. Now we have question number 4, which is an MCQ. You get in fact 10 MCQs as for your CBSE board exam is concerned. So we'll simplify it and try to see what is the final answer. So that matches with the options. There are 4 options given. Question 4th, part number 1. It says 9 of secant square A minus 9 of tan square A. What is its value? This is part 1. You have 4 options. 9 secant square minus 9 tan. 9 could be taken common, my dear friends. You get secant square A minus tan square A. So that has to be secant minus tan. Just now we derived the result. 1 plus tan square is secant square. So secant square minus tan square is 1. So this has to be 9 into 1. The final answer is 9. What are the options? First option is A is 1, B is 9. So it matches with option B. So we'll say it's B option. Now we have one more part. Let's take that part. It's part B. This is question 4, part 2. 1 plus tan plus secant. 1 plus tan theta plus secant of theta into 1 plus cot minus cosec. 1 plus cot theta minus cosec theta. So we are asked to simplify it, and you have 4 options: 0, 1, 2, 3, 0, 1, 2, and minus 1. So options are A is 0, B is 1, C is 2, D is minus 1. Out of 4, we have to see which is the best one, which is the correct one in fact. 0, 1, 2, and minus 1. So which is the correct option? Now, how we are going to do this? We're going to simplify this further. This is a product of trigonometric expressions. They are in terms of the higher T ratios, tan, secant, cot, cosec. And usually when you work with trigonometric expression, or you work within trigonometric identity or in trigonometric equation in terms of the higher T ratios, express them in terms of the basic T ratio. That is sine and cos. You should be knowing tan is sine by cos, cot is cos by sine, and secant is 1 by cos, and cosec is 1 by sine. So I'll express it in terms of the basic T ratio and do the simplification. This is going to be 1 plus tan will be sine upon cos, and secant will be 1 upon cos of theta, and this will be 1 plus cot will be cos theta upon sine of theta, minus cosec will be 1 upon sine of theta. So I could simplify it this way. Now let's take the LCM. This is going to be cos theta plus sine theta plus 1 whole upon cos of theta. LCM. This multiply cos up and down, cos theta plus sine theta plus 1 upon cos of theta. And this has to be sine theta plus cos of theta minus 1 whole upon sine of theta. Now we are going to simplify it further, taking help of, in fact, the complementary results won't be involved because angles are, only theta is there. There are no acute angles that sum up to 90. I think we are going to take help of the identities, 3 basic identities. Now, what are we going to do? We are going to take the product. Now, if you observe, cos plus sine is same as sine plus cos. If this is A, this is also A. And this is 1, so if this is B, this is also B. And the connecting sign is plus and minus. Means I'm going to use A plus B into A minus B in the numerator. A plus B into A minus B. So that is a famous identity, a plus b into a minus b. That is a square minus b square. This you have done in grade 9th. A plus b into a minus b will be a square. A is my cos theta plus sin theta, square of that, minus b square, that is 1 square. Whatever the denominator, it will remain as it is, cos theta into sin of theta. Now we can simplify this identity, a plus b whole square. So a plus b whole square will be cos square theta plus sin square theta, a square plus b square, a plus b whole square. One more identity we are going to use, a square plus b square plus 2ab plus 2a into b, cos theta into sin theta. Then minus 1 as it is, whole upon cos into sin, cos of theta into sin of theta. Now further to be reduced, my dear friends, cos square theta plus sin square theta is 1, and you have minus 1 also, so this is going to cancel with minus 1. What you are left with, you are left with 2 cosine. In the numerator 2 cos theta into sin theta, and in the denominator cos theta into sin theta. So this is going to cancel and you are left with 2, that is option C. So C is the correct option as far this expression was concerned. So we have simplified it and the answer is option C. I don't think this has to be a 1 mark sum. This is worth 2 marks. But maybe sometimes this is asked for 1 mark, so you have to be prepared for that. Okay, that was part 2 of question number 4. Now, there are 2 more parts. They are very simple, like secant plus tan into 1 minus sine. As I said, when you deal with higher t ratios, express them in terms of the basic t ratios. We have question number 5, which has 10 identities, and you are asked to prove these identities. Angle involved are all acute angles, and you get identities, you get questions on identities, you get questions worth 4 marks. And many students, they complain that, sir, trigonometry is difficult. Difficult in the sense that when they are asked to attempt questions based on trigonometric identities, they find it difficult. Now, why they find it difficult? Although questions are being asked from the textbook or beyond the textbook, maybe from R.D. Sharma, but they are based on the basic 3 identities. So they are difficult in the sense that variety is there, because you have to, it's not what you do in one identity, same is to be done in the second identity. But there is a common fabric as for all these identities are concerned, what we do. How you go about them. Usually you have left hand side and you have right hand side. So students ask, which side should we take? Should we take left hand side and prove it equal to the right hand side, or should we take right hand side and bring it back to the left hand side, or we have to take both the sides, left hand sides as well right hand side? Now it depends on the question, but most of the time we work on that side, which is quite hefty, which is in terms of the higher t ratios. You work on that side, wherein you could do the LCM, you could simplify that side. And that happens to be most of the time left-hand side, but this is not a rule that always you have to take left-hand side. So my suggestion would be take that side of the trigonometric identity that you have to prove, which is expressed in terms of the higher t ratios, like tan, cot, secant, and cosec. And one more thing which you have to remember is do make use of LCM wherein things permit. And we are using most of the time this identity a plus b into a minus b, or a plus b whole square and a minus b whole square. So I will try to see how many sums I am able to finish in this video, and I have identified some extra sums which are beyond the textbook. So I will try to attempt those sums also. So first we'll rub this. So first part says cosec theta minus cot of theta, square of that. This is part 1. prove this is equal to 1 minus cos of theta upon 1 plus cos of theta. So if you are asked to prove this identity, any trigonometric identity, so what is the common way of doing them? Express higher t ratios in terms of the basic. My higher t ratios are on the left hand side, my right hand side is expressed in terms of the basic t ratio. So what I will do, I will take the left hand side. So I will work on the left hand side. Left hand side is cosec theta minus cot theta, square of that. Now if we simplify this, cosec theta will be 1 upon sin theta, and cot theta will be cos theta upon sin theta, square of that. So this could be expressed as 1 minus cos theta, square of that, and denominator sin square theta. I have taken the individual squares for the numerator and the denominator. Have an eye on your right hand side. My right hand side is 1 minus cos in the numerator. I did prepare that 1 minus cos. You have two factors for that. But denominator is 1 plus cos. You have sin square. Now see, 1 minus cos in the numerator is nothing, product of 1 minus cos into 1 minus cos theta. Now sin square I could express as 1 minus cos square theta. In fact, 1 square minus cos square. How come? My dear friends, famous identity, sin square plus cos square is 1. So your sin square theta is 1 minus cos square theta. Why I am doing this? I am doing this to generate, to prepare 1 plus cos in the denominator. Numerator will remain as it is, 1 minus cos into 1 minus cos. My dear friends, this is 1 or 1 square. If I take it 1 square, so I will be using the result a square minus b square in the denominator. A square minus b square. So use a square minus b square in the denominator. That is a plus b into a minus b. A plus b into a minus b. Right? So this 1 minus cos cancels with 1 minus cos. We are left with 1 minus cos upon 1 plus cos. That is the right hand side. So we have verified this. 1 minus cos upon 1 plus cos of theta. That is the right hand side. Now if we take the right hand side, we can bring it back to the left hand side, but that would be quite tedious as compared to taking left hand side and bringing it to the left hand side, bringing it to the right hand side. We'll move further. Now second part, third part, okay, I think they are all important parts. Second part says, prove that cos of A upon 1 plus sin A plus 1 plus sin A upon cos of A, that is equal to twice secant A. Let me cross check it. So, yeah, cos upon 1 plus sin A plus 1 plus sin upon cos, you have to show that is twice secant of A. So quite obvious, we will work on the left hand side, quite hefty. This has to be worked. It has to be brought back to 2 secant A. So let me take the left hand side. This is my left hand side. So what I will do, your right hand side is 2 secant A. So I am using the left hand side. I did a shortcut, my dear friends. This is my left hand side. This is to be shown equal to 2 secant A. Now, this is already in terms of the basic t ratios. So we can't express it. They are already in the basic format. So we'll do the LCM. So cos will come here. You will get cos square A plus this will be 1 plus sin A into sin A. 1 plus sin A whole square whole upon 1 plus sin A into cos of A. So I took the LCM. The LCM was 1 plus sin A into cos of A. So working on that, I got cos square here, 1 plus sin A whole square, 1 plus sin into cos. Now, this will be written as it is cos square A. Now, 1 plus sin A whole square will expand it using A plus B whole square. A plus B whole square would be A square plus B square plus 2A into B. You can write that in the examination using a plus b whole square, a square plus b square plus 2ab. And the denominator is as it is, 1 plus sine a into cos of a. Now, we can combine, my dear friends, cos square plus sine square. Cos square a plus sine square a is nothing but 1. Plus you already have one more 1. Plus 2 sine a. Whole upon 1 plus sine a into cos of a. 1 plus 1 sums up to 2. So you have 2 plus 2 sine a divided by 1 plus sine of a into cos of a. We can take 2 common in the numerator. If you do that, you are left with 2 into 1 plus sine a upon 1 plus sine a into cos of a. So 1 plus sine a will go with 1 plus sine a. What is the remainder left? You are left with 2 upon cos of a. That is 2 into 1 by cos a. That is nothing but 2 secant a. And that was your right hand side. So we had to simplify this in terms of taking the LCM, make use of identity a plus b whole square. We use a plus b whole square here. Previously we used a plus b into a minus b, that's a square minus b square. So we'll move further. There are so many identities to be derived. Now we have part 3. I would like to take part 3, then there is part 5, and part 5 is basically a family of questions. There are 6 questions. If time permits, I will take those. I have written some of the sums which belong to that family. There are 6 questions based on a particular format. So let me first take part 3. This is question 5, part 3, trigonometric identities. Prove that tan of theta divided by 1 minus cot of theta plus cot of theta divided by 1 minus tan of theta. We have to show this is 1 plus sec theta, secant theta into cosec theta. It's a big sum, my dear friends. Tan upon 1 minus cot plus cot upon 1 minus tan is 1 plus secant into cosec. Okay, I'm verifying if I have copied it correctly. Okay, 1 plus secant into cosec is my right hand side. So we'll be using the same procedure expressing higher t ratios in terms of the basic t ratios. Tan and cot are to be expressed in terms of sine and cos. And obviously we are going to take the left hand side. So I will take my left hand side, that is tan theta upon 1 minus cot of theta plus cot of theta divided by 1 minus tan of theta. So if I express them in terms of the basic, tan will be sine theta upon cos of theta divided by 1 minus, and what is cot? It's cos upon sine. It's the reciprocal of tan, so it will have cos upon sine. Plus cot is again cos theta upon sine of theta divided by 1 minus tan theta is sine theta upon cos of theta. So this was the first step, expressing in terms of the basic t ratio. Now what next? We'll take the LCM in the denominator. Numerator is already simplified. So numerator will be as it is, sine theta upon cos of theta divided by sine theta minus cos of theta whole upon sine of theta. Plus this will be same cos theta upon sine of theta divided by, if you take the LCM, this will give us cos theta minus sine theta whole upon cos of theta. Okay. Now I don't have space here. I need to make space on the top. So I will be rubbing this. So you have a rational number in the numerator, again a rational number in the denominator. This will be written as sine theta upon cos theta into, this will get reciprocated. Sine theta upon sine theta minus cos theta. A divided by B divided by C by D is A by B into D by C. So this goes to the numerator, but the reciprocal of that. Same goes to this term, cos of theta upon sine of theta into cos theta upon cos minus sine. Okay. Now this will give me sine square. I will try to cancel, but nothing is to be cancelled here. Here also you can't cancel, but we could take cos into cos is cos square. Sine to sine is sine square. And what about this term and this term? Are they same? This is A minus B, that's B minus A. Is A minus B equal to B minus A? No, it's not equal to. But what I do, if I have to A minus B and B minus A equal, I have to say A minus B is minus times B minus A. In fact, A minus B whole square is B minus A whole square, but A minus B is not equal to B minus A. Two numbers are not commutative as far as subtraction is concerned. 2 minus 1 is not equal to 1 minus 2. So I will express this as minus times sine minus cos, then take sine minus cos common. Right? So I will write this as sine square theta divided by cos theta into sine minus cos as it is. And here this will be cos square theta. This will be sine theta. This B minus A I am writing as A minus B, but minus times. Cos minus sine is minus times sine minus cos, minus times sine minus cos. That minus will be expressed here. So that we are in a position to take sine minus cos common in the denominator. That means I can take 1 upon sine minus cos, sine theta minus cos theta, common in the denominator. I am left with sine square theta in the numerator divided by cos theta minus cos square theta upon sine theta. It's a big sum, my dear friends, worth 4 marks. So we have expressed it up to this level. Now what next? We are going to take LCM here. So that would be the next step as 1 upon sine theta minus cos of theta. This will give us sine square into sine is sine cube theta. Cos into cos square is cos of cube theta divided by cos theta into sine theta. Again, an identity to be used of grade 9th. This is A cube minus B cube in the numerator. See, A cube minus B cube is nothing but A minus B into A square plus B square plus AB. A cube minus B cube has other version also. I am using this result just to factorize it. A cube minus B cube is A minus B into A square plus B square plus AB. So this result we will use. This we will use for sine cube minus cos cube. We have to move further. I'm going to rub this. Okay, now this will give me 1 upon sine theta minus cos theta. So when you use A cube minus B cube, you get A minus B. A minus B. A cube minus B cube. A minus B into, this is nothing but square of the first term, this is square of the second term, this is product of the first and second. So A cube minus B cube is A minus B into A square, that is sine square theta, plus B square, plus A into B, sine into cos. Sine theta into cos theta in the numerator. Close it. And what about the denominator? It's cos into sine. Cos of theta into sine of theta as it is. Are we going to cancel any term? We can cancel sine theta minus cos theta because this is in product. What you are left with? You are left with sine square theta plus cos square theta plus sine theta into cos theta divided by cos theta into sine theta. Now sine square plus cos square, that will give you 1. Sine square plus cos square theta is 1 plus sine theta into cos of theta, and denominator is cos of theta into sine of theta. Let's see what was our right hand side. The right hand side is 1 plus secant into cosec. 1 plus secant into cosec. Now that means there's nothing in the denominator. Let me divide. This will be 1 upon cos of theta into sine of theta plus sine theta cos theta upon cos of theta into sine of theta. This will be 1 upon cos theta into 1 upon sine theta plus this is nothing but 1. What is 1 by cos, my dear friends? That is secant. Don't forget these results. And 1 by sine is cosec theta plus 1. And that is your right hand side. Just cross check it. You have to show that this is 1 plus secant into cosec. 1 plus secant theta into cosec theta. So that way we have finished this part. This was the third part. Now other parts are same. You have to apply the same logic. Now I'm going to take one important result. Basically there are 6 questions in totality. It's basically a family of trigonometric identities. Let me first show you the format. And you have one question, that is part 5. Let me cross check. Yeah, that's part 5 as far as this textbook is concerned. So I will show you how those 6 results are related and what all you have to do in all the 6 parts. You have to do the same process. I'm going to rub it first. Basically, it's a family of questions. Let me show you what it's all about. You have to say, let me first write one result. You have to prove that, for example, it's tan theta plus secant theta minus 1 divided by tan theta minus secant theta plus 1. You have to prove this is sine theta plus 1 upon cos of theta. So it's in terms of tan and secant, first result. If you reciprocate it, you will get the second result. That means tan minus secant plus 1 upon tan theta plus secant minus 1. Answer would be cos theta upon sine theta plus 1. So I'm taking 1, but second result could be derived from this. Okay. Now this is in terms of tan and secant. Other result is in terms of cot and cosec. What's the result? Prove cot theta plus cosec theta minus 1 divided by cot of theta minus cosec theta plus 1. This is nothing but it will be cos of theta plus 1 upon sine of theta. You reciprocate it, you will get one more result. Again in terms of cot and cosec. So its answer would be sine theta upon cos plus 1. Your third is which is given in the textbook. That is part 4. Cos A, I'm taking it in terms of theta now. Cos A minus sine A plus 1. Cos of A, so cos of theta minus sine of theta plus 1 divided by cos of theta plus sine of theta minus 1. You have to show this is equal to cosec plus cot. Cosec plus cot. Cosec plus cot, if you express in terms of the basic T ratio, it will be 1 plus cos theta upon sine theta. As I wrote these two in terms of sine and cos, this also could be expressed in terms of sine and cos. This will give 1 by sine, cos by sine, 1 plus cos by sine. Now see the relation. So this will give me one more result. So 2, 2, 4 to 6. Okay, they are in terms of, first result is in terms of tan and secant. Second is in terms of cot and cosec. Third one is in terms of sine and cos. Okay. What's the other way to retain it, to identify it in the examination? My dear friends, if you see this, the order of the signs, plus and minus, no two signs are same. After plus you have minus. If you go in the clockwise direction or anti-clockwise direction, see, plus followed by minus, minus followed by plus, plus followed by minus. If you don't have this order, then that question doesn't belong to this group. So that would be a different sum. So mind it, you go in the clockwise direction or anti-clockwise direction, no two signs are same. Minus is followed by plus and vice versa. Minus, plus, minus, plus, plus, minus, plus, minus. So this way you will identify these questions. They are 6 questions. Tan secant, because your identity is in terms of tan secant. 1 plus tan square is secant. Cot cosec, 1 plus cot square is cosec square theta. And sine cos, sine square plus cos square is 1. Now if you have these two, things are easier. This is to be transformed to one of these two. So let me do the first one. Now, logic is same in all the 3. In fact, all the 6 parts. There are 6 in totality. So what we are going to do? Are we going to express in terms of the basic T ratio? Because you will say, sir, just now in the beginning you said whenever you work with T identities, you have to prove them. Whenever you come across higher T ratios, express them in terms of the basic T ratios. But there is an exemption. They are in terms of higher T ratios, tan and secant, cot and cosec. I am not going to change them, express them in terms of the basic T ratios. We can do that, but if you work the way I'm going to teach you, that is quite convenient, and in 2 to 3 steps we are going to get the answer. Now, what we are going to do, in all these cases, this is going to convert it to this or this. What you do, you go to the one that has the minus sign with it, that is this minus 1. Minus 1. Maybe that minus 1 is in the numerator or that minus 1 is in the denominator. Wherever you have minus 1, we focus on that minus 1. We are going to express that using an appropriate identity. So just do remember, go to the minus 1, be it in the numerator or in the denominator. I have minus 1 in the numerator here, here also. If you reciprocate it, you will get the other result, so you will have minus 1 in the denominator. Now what we are going to do, we are going to express that minus 1 in terms of the appropriate identity. So this is my left hand side and my right hand side is sine theta plus 1 upon cos. So let me write my right hand side. Okay, my right hand side is sine theta plus 1 upon cos theta. This is my right hand side. I will take the left hand side. Okay, this is my left hand side. I said express minus 1 in terms of the appropriate T identity. My dear friends, 1 plus tan square is secant square. So 1 is secant square theta minus tan square theta. This result we are going to use. 1 is secant square minus tan square. Which one? The plus 1, the minus 1, or both the ones? No, the minus 1 with the minus sign. So rest remains same. This remains as it is. So tan theta plus secant theta is as it is, minus this 1 will be replaced by this result. So I'm going to replace it by secant square minus tan square theta. And denominator as it is. Tan theta minus secant theta plus 1. One more step, 2 more steps required. Now use a square minus b square. Very famous result. Use a square minus b square, that is a plus b into a minus b. So this is as it is, tan of theta plus secant theta. So minus a square minus b square is secant theta plus tan theta into secant theta minus tan theta. A square minus b square, a plus b into a minus b. Denominator we write as it is, tan of theta minus secant theta plus 1. What we are going to do, this term and this term, you observe they are same. You have a binomial in the numerator. Tan plus secant can be taken common. So when I take tan plus secant, so what you are left with? You are left with 1. If you take tan theta plus secant theta common, you are left with 1 minus secant minus tan. So if I take 1 common, So this is nothing, sorry, I have to take tan plus, basically I don't have space here. I'll move on to the top. This much is sufficient. Taking tan plus secant common in the numerator. Tan plus secant theta is common. So bracket starts, you are left with 1 minus this expression. That is secant theta minus tan theta, but in the brackets. And denominator as it is. Tan theta minus secant theta plus 1. Okay? Now, if you observe this expression, and this expression is same. Just see, 1 minus secant plus tan. 1 minus secant plus tan. I could make the second step, but we could just finish it here. 1 minus secant minus plus tan. So this expression cancels with this expression. We are left with tan theta plus secant theta. You can have this as an answer also, but if you express in terms of the basic T ratios, this will be sin theta by cos theta plus 1 upon cos theta. That is nothing but sin theta plus 1 upon cos of theta. That is your right hand side. Okay, so we have proved that tan plus secant minus 1 upon tan minus secant plus 1 is nothing but 1 plus sine upon cos. Same logic goes to the cot and cosec. Now what about sine and cos? That I would just show you. So that is your part 5 of your textbook. It says prove that cos of A minus sine A plus 1 divided by cos A plus sine A minus 1 is nothing but cosec A plus cot of A. Cos minus sine plus 1, cos plus sine minus 1. Now, I said when you have, in terms of cos and sine, we are going to change it to tan and secant. Why? Because, my dear friends, if you use the same logic, you go to the minus 1 and replace that minus 1 by the appropriate identity. That means in this case, 1 will be replaced by sine square A plus cos square A, as we did in the previous sum. But you are not going to make use of A square minus B square. You can't factorize this further. Sine square plus cos square can't be factorized. It could be maximum written as sine A plus cos A whole square minus 2 sine A cos A. You can't write the factors in the product as you could do for A square minus B square. Understood? So in that case, what we do, when you come across in terms of sine and cos, we bring it to tan secant or cot cosec, depending on which expression is in the beginning. In the beginning, you have cos. If it starts with cos, you divide numerator and denominator by sine. I repeat, this expression, again, that minus plus order is followed, minus plus, and so on. So I will change it to tan and secant, depending which T ratio is in the beginning. If cos is in the beginning, divide numerator and denominator by sine. If sine was in the beginning, divide numerator and denominator by cos, the opposite. So we will divide the numerator and denominator by sine of A, because the numerator and denominator, it starts with cos. That's why you are dividing by sine. When you divide numerator and denominator by sine, this becomes cot of A minus 1 plus cosec A. Okay? Upon cot of A plus 1 minus cosec A. This is nothing but cot A plus cosec A, keep 1 at the end, minus 1, cot A plus cosec A minus 1 upon cot A minus cosec A plus 1. So I have brought it to cot cosec format. Now you have, in terms of cot and cosec, see, the order is still there of the plus and minus sign. So you have to replace this minus 1 by the appropriate result. It will be 1 plus cot square is cosec square. So you will replace 1 by cosec square A minus cot square A. And you will do the same process that I did in terms of tan and secant. expressing -1, which is in the numerator, by cos square minus cosec square a minus cot square, use a square minus b square, then take cosec a plus cot a common and cancel out. You will get the final answer as cosec a plus cot a. I hope you will work on it, and my advice that you should try the remaining sums of this textual exercise as well as the solved examples. So I hope this video is going to help you. So we have finished the introduction to trigonometry topic. So all the best to you. Happy learning. Thanks.